നമുക്കിന്ന് ഫിൽട്ടർ സർക്യൂട്ട്സ് ഏതൊക്കെയാ നോക്കാം. വൈ ഡു വി നീഡ് ഫിൽട്ടേഴ്സ്? നമ്മൾ കണ്ടിട്ടുണ്ടായത് റിപ്പിൾ ഫാക്ടർ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഔട്ട്പുട്ടിൽ we have seen that fluctuating DC. So the ratio of AC by DC to the DC current in the output is known as ripple factor. That is, ripple factor is AC by DC. Then why do we need filters? Because of the ripples. Ripple in the signal denotes the presence of some AC component, and we have to remove this AC component to get a pure DC output. So we need a filter circuit to smoothen the rectified output to a pure DC signal. So we can define a filter circuit is one which removes the AC component present in the rectified output and allows the DC component to reach the load. From this figure you can see that this is the rectified output. This is a full wave rectifier output, and if it passes through the filter circuit you will get a smoothened pure or perfect DC signal. This is an ideal filter output. For that we use different components, inductors and capacitors. An inductor allows DC and blocks AC. Because of the inductive reactance, XL is equal to 2 pi FL. F is frequency, L is the inductance. 2 pi FL. So if frequency is there or frequency increases or frequency is present, there is a inductive reactance. So it blocks AC component and allows the DC. That means if in the case of DC frequency 0, so F is 0, inductive reactance XL is 0. This is an inductor, right? XL is 0. So there is no resistance for the direct current. So it allows freely the DC and blocks the AC. Then the capacitor allows AC and blocks DC. In the case of capacitive reactance, that is XC is equal to 1 by 2 pi FC. If F is there, there is a negligible capacitive reactance. Or as increase in the frequency, the capacitive reactance decreases. Is in the case of DC 1 by 2 pi FC, F is 0, then 1 by 0 it's infinity. That means capacitor allows AC and blocks DC. So we can use these capacitor and inductor to filter out the AC component. A series inductor filter. As an inductor allows DC and block AC, a filter called series inductor filter can be constructed by connecting the inductor in series between the rectifier and the load. And this figure shows the exact operation of the series inductor filter. So the ripple or the rectified output is passing through the inductor. These AC components will be blocked by this inductor and only the DC output will get. Now this is the output of the filter rectifier in the series using series inductor filter. Then in the case of capacitor filter circuit, capacitor allows AC through it and blocks DC called shunt capacitor filter. Oh, you see from this figure, you can see that this is the output of a full wave rectifier, which is connected to the shunt capacitor. Then it passes through the circuit. What happens? The AC feels negligible resistance through this capacitor. So this capacitor allows AC component through this circuit. And the output across the load, we will get only the DC component. So here you can see the output of a capacitor filter circuit. This is not exactly a pure DC, and we can construct because of some leakage through the circuit. And if you increase the capacitance, you can also reduce the ripples, because the capacitance, as increasing the capacitance, you are decreasing the resistance of the position felt by the AC current. Then we can combine the inductor and capacitor as LC filter, inductor capacitor filter. The circuit is shown like this, and you can see that here you will get uh, this much AC in the output, and that is again filtered by this capacitor. So the output, again the ripple factor reduced, or you will get almost smooth rectified output in the case of LC filter. And another filter is pi filter, that is capacitor input filter, and the two capacitors and inductor is connected as pi. Okay, therefore it is known as pi filter. Pi filter. The circuit design is shown here, and we know that when AC, the rippled output is coming from the rectifier, full wave rectifier or half wave rectifier, the AC component pass through this capacitor. The remaining AC and DC, the AC will be blocked by the inductor, and we will get a small AC and large DC in the output of the inductor, and the small DC AC is again filtered out by the C2. Then we will get a smooth or almost pure DC in the output. Okay, now we can watch a video, then we can end the
Filter is used to remove the AC component which is present in the rectifier output, that is pulsated DC. The different types of filters are inductor filter, capacitor filter, L-section filter or LC filter, pi filter or CLC filter. Inductor filter. The reactance of the inductor is given by inductor filter allows AC and blocks DC signal. It is always connected in series. High-value inductor or choke is connected in series between the rectifier and the load resistor. Inductor opposes the change of current and smoothens the output. Choke offers high impedance to the ripple components. Choke offers zero impedance to the desired DC components. Ripple components are removed largely. Simple series inductor filter is not properly used. It is preferred to associate a shunt capacitor C with series inductor L, thereby converting it into an LC filter. Inductor filter. Once the output of the rectifier passes through an inductor, it blocks the AC component and allows only the DC component to reach the load. The rippled factor of inductor is given by, it shows that the ripple factor will decrease when L is increased and RL is decreased. When the load current is high, the inductor is more effective. The larger value of the inductor can reduce the ripple, and at the same time, the output DC voltage will be lowered as the inductor has a higher DC resistance. To analyze this filter for a full wave, the Fourier series can be rewritten as the DC component is, by assuming the third, the higher terms contribute little output. The output voltage is given as the diode, choke, and transformer resistance can be neglected since they are very small compared to load resistor. Therefore, the DC component of current is given as The impedance of series combination of L and RL at 2 ohms is given as. Therefore, the AC component, therefore, the resulting current I is given by the ripple factor, which can be defined as a ratio of the RMS value of the ripple to the DC value of the wave, is capacitor filter. In full wave center tapped rectifier, during positive half cycle diode D1 conducts and it is in forward bias, and diode D2 is reverse biased, and the capacitor gets charged to Vm in the time period T1. When the input voltage falls below the capacitor voltage, both the diodes will be reverse biased, thus the capacitor starts discharging through RL. During the negative half cycle, same procedure repeats except D2 on and D1 off. The ripple waveform will be triangular as shown in the output waveform. The reactance of the capacitor filter is given by capacitor is charging to the peak value of I in the forward bias and discharging in the reverse bias. If T2 is discharging time, then the amount of charge lost is equal to T2 into average current. For better filtering action, let T2 is equal to T by 2. The ripple waveform will be triangular and the RMS value of the ripple is given by. Therefore, from the above equation we get, therefore, the ripple factor is given as capacitor filter. The simple capacitor is the most basic type of power supply filter. Applications: useful on extremely high voltage, low current power supplies for cathode ray and similar electron tubes. Requires very little load current from the supply. Useful if power supply ripple frequency is not critical. Consists of a high value capacitor placed directly across the load impedance. Capacitor gets charged. Capacitor stores energy during the conduction, delivers energy to the load during the non-conduction period. Current flows through the load resistor and gets increased. Ripple component is reduced, useful for all types of rectifiers. Half-wave rectifier with capacitor filter. The output voltage during conduction period is given as. The output voltage during the non-conduction period is given as. The cutout angle is given as. Ripple factor is given as. Capacitor filter with full wave rectifier. The diode current during the conduction period is given as. The output voltage during the non-conduction period is given as. The cutout angle is given as. Ripple factor is given as.
In order to
Thank you.